Okay, so this lesson is over adding and subtracting rational expressions. Today in class, we will be adding and subtracting rational expressions, and you guys are going to be expected to determine the sum or difference of rational expressions with exponents of 1 or 2. So as we've talked about in the previous section of this unit when we did adding and subtracting, we said that rational expressions are pretty much just your fractions. You're just dealing with fractions. And we said that when you multiply and divide fractions, you do not have to have common denominators because it's just you multiply straight across, and with division, you do your same stay change flip. When we do adding and subtracting, though, just like with fractions, we do require common denominators. So let's just take a second, kind of go back to elementary school, and try a fraction example. So if I gave you 1/3 plus 2/5, and I wanted to add these together, I would have to make sure that my denominators are the same. So the way that we always did that is we multiplied by the other denominator, right? So if I want my denominator to be 15, I'm going to multiply this by 5 to get 15. And I'm going to multiply this by 3. But it doesn't just stop there because we can't just randomly say I'm going to multiply by a 5 on the bottom. You can, however, multiply by a 1, right? I can multiply anything by a 1. I could do 5 times 1 because it doesn't change anything. 5 times 1 is still 5. So in order for me to be multiplying by a 5, or by a 1, I'm really multiplying by 5 over 5, right? So the kind of quick way of saying it is what we do to the bottom, we also have to do to the top. So here I have to also be multiplying by a 3. And so this ends up changing it so that I have 5 over 15 plus 6 over 15. Now that my denominators are the same, I end up being able to just add across. Okay, so I have 5 plus 6. You just add your tops together, and so you get 11. And then the denominator doesn't change. It stays 15. And that's how we do regular fractions. So when we do rational expressions, we talked about how rational expressions have fractions in them. They have x's in your denominator. So your steps, I don't know why it says 4, 5, 6, 7, 8, but we are going to be starting our steps the same way we did our steps with the multiplying and dividing and the simplifying. So we're going to start by factoring. What you should notice here, though, is that it doesn't say factor everything, right? It just says factor your denominators. And when we go through our example, I'll show you why you would not want to factor your numerators. If you factor your numerators, it's not the end of the world. It's just going to put more work on you in the end because you'll have to end up foiling them back out. So we're going to start with factoring our denominators. And then if the denominators are the same, then we pretty much are done, right? It's just like when we did fractions. If I gave you a fraction that said 1/2 plus 1/2, well, my denominators are already the same. I don't have to go through all of this extra step. So it would just be 2/2, right? Or 1. So if your denominators are already the same, then you can just go ahead and add or subtract the numerators and place them over that common denominator, which in our little example on the left was the 2, right? We added our numerators and we put them over our common denominator of 2. Okay, so I'm going to just highlight common here. We'll come back to this, but you always want to find that common denominator, just like what we did here with the 15. So our 3 and our 5, we found a common denominator of 15, and that's what we used. So that's like the basic example. That would be the easiest way of doing it, or the easiest type of problem. So then what if the denominators are not the same? So if the denominators are not the same, like our example with the 3 and the 5, then what you're going to do is you're going to rewrite those denominators as equivalent fractions with the same denominator. That sounds kind of repetitive, But essentially, it's just like that fraction example we did there. If they're not the same, we need to make them the same somehow. Okay, so there's a little reminder here. Remember that there are invisible parentheses around each numerator and denominator. So if you look here at this example, see how the x minus 3 on the bottom doesn't have parentheses around it? Sometimes people can get confused with that and just assume that the x is separate and that the 3 is separate. But we talked about in our previous section with multiplying and dividing, we said that this is a set. So just don't forget that there's those parentheses there that you have to take into consideration. And so then the very last thing is to reduce if necessary. So we practiced a lot with simplifying, like doing all that canceling stuff. So you have to make sure that if there is something to reduce, that we can reduce it at the very end. So let's go through this example. Made it a little easy on you. Step 1's done. The denominator's already factored there. So if you look at this, the denominators are not the same. This one has an x plus 3 and an x minus 3. This one just has an x minus 3. So what we do is we find an LCD, least common denominator. And that least common denominator is going to be basically including everything. So here I have an x plus 3. Here I have an x minus 3. So that's got to be part of all of it, right? Because I can't just say x plus 3 because then it wouldn't include the x minus 3 that's needed. Now this one has an x minus 3, but I don't have to write it again because it's already there. Something that I read that was kind of interesting was thinking about the whole like keeping up with the Joneses. I don't know if you've heard of that, but basically you want whatever they have. So think of it like backyards, right? So this person has an x plus 3 in their backyard, right? So that means that I want to have an x plus 3 in my backyard. This person has an x minus 3, so I want to have an x minus 3. This person wants an x minus 3, but I've already got that, so I'm good. I don't have to write it again. So hopefully that kind of helps finding your LCD, but basically you just want one of everything that each person has. So once you know your LCD, that's what you're trying to become. So like over here, our LCD would have been 15. And so what we did is we looked at it and we said, okay, well, this is only a 3, so how can I make it a 15? You're going to do the same thing over here. So look at it one at a time. This denominator, it already has what it needs, right? It has the x plus 3, it has the x minus 3. This must be the Joneses, right? It's already got everything. So I can just rewrite this. I don't have to change anything. And since I didn't have to change anything on the bottom, I also don't have to change anything on the top. Okay, so I'm going to put my plus sign. Now this guy, he's not keeping up with the Joneses. So we've got to make sure that he has everything. So we look at our LCD. What does he need? Well, he has an x minus 3, but he doesn't have an x plus 3. So what I want to do here is I want to multiply this by an x plus 3. So now he has what he needs, right? But you have to remember that what we did over here, we couldn't just say, let's multiply the bottom by a 5. We had to multiply it by a 1, right? 5 over 5. So the same thing goes here. If I multiply the bottom by x plus 3, I also have to multiply the top by x plus 3. Keep it even, right? Because now I'm just multiplying times a 1, so I'm not actually changing my equation. So when I rewrite this, I'm going to have 2 parentheses x plus 3 over x minus 3, x plus 3. Now, it seems a little repetitive because this is exactly this. I'm just rewriting it out. You obviously don't have to. You could just leave it like this and then move on to the next step. So now that our denominators are the same, as you saw over when we did our fractions here, all we had to do was add our numerators and write it over our common denominator. That's what step 6 is saying. That's what step 5 kind of was saying. So once the denominators are the same, add or subtract the numerators and place them over the common denominator. So my answer here, I'm going to have to add these tops together. So some of you can do that in your head, right? Keep in mind that this is going to have to FOIL out. So So, or distribute out, I'm sorry. So what we're going to end up with is 5x plus 2x, right? Plus 6. So 5x plus 2x makes 7x, and then that 6 just gets added at the end. Okay, so what do we put it over? Some people make the mistake of putting it over this and this. You don't want to write it twice, okay? Just like what we did before with these, we just wrote the 15 one time. That's your common denominator. So now we're going to write that once on the bottom. So the very last step said reduce if necessary. Some of you guys may be seeing, well, there's no x plus 3's or x minus 3's on the top. You're correct. This problem, you can't simplify any further. But if you had something up here like a trinomial, like a quadratic trinomial, you would probably want to check and see if you can factor it and if any of those factors will cancel out. Because if they do and you don't factor them, you don't cancel them out, then you're not going to get it right. It won't be fully simplified. So this is going to be your answer here. Now, just like we did with the simplifying and the multiplying and dividing, we're going to look for restrictions. And again, those restrictions don't tell us anything right now. They don't really mean much. But we're going to get into solving soon, and we're going to get into finding attributes of rational functions. And we are going to really want to make sure that we understand restrictions before we get into that unit, because there's going to be a lot of harder stuff that's going to happen. And I don't want to spend so much time on restrictions that we can't focus our time on the solving. So we're going to find our restrictions here just for practice. When we did it in multiplying and dividing, we said that you have to do it before you cancel anything out, right? Same thing goes here. If there was something that I could cancel out, I would want to find my restrictions before that. But we kind of have a little hint here. You found an LCD. That LCD includes every single thing that was at some point in your denominator, right? It included everything from both fractions. So when you're finding your restrictions, you can just find them from this LCD. So what are our restrictions going to be? Well, we have an x plus 3, so negative 3 would make that a 0. We have x minus 3, so positive 3 would make that a 0. So these are your restrictions. Again, they don't really tell you anything when it's just an expression like this, but when we get into solving and we have those equations where x is actually representing a number, then those restrictions are going to tell us important pieces of information. Okay, so on the next page, we have